Let us consider we have a graph in which we have to consider in y-axis is temperature and x-axis we have to consider the composition of liquid. What we are doing here, consider two component, that is A solid, B solid, and consider we have take A solid as 80 gram, B solid as 20 gram. This is the system, and this system we are heating till all solid melt to form homogeneous here A and B both are liquid and B both are liquid, but this liquid phase contains 80 gram of A, 20 gram of B, that is 80% of A, 20% of B. So consider this line, this y-axis line represents A and this represents B. When A is a pure component, that means composition of A is 100%, and B is pure component, that means composition of B is 100%. When A is 100%, then B will be 0. When B is 100%, then composition of A will be here 0. So consider these are the point, and this point represents the composition of solution phase, that means 80% of A and 20% of B at this composition. Let us consider we have this point and this point. This point represents freezing point temperature or melting point temperature of component A. This point represents freezing point temperature or melting point temperature of component B. So when we are taking in a system 80 gram of solid A and 20 gram of solid B and we are heating, then we get a homogeneous liquid phase which have composition which contains 80 gram of solid A and 20 gram of B, that means 80% of A and B is 20%. So the liquid phase temperature, since all the solid A and B are melted, that means the temperature we are getting, consider here, which is more than melting point of A and melting point of B. Consider this point is small a. This small a represents the temperature of the solution phase and composition. This point A, this is the point A, and this point A represents temperature at which the solution phase is present and the composition, that is 80% and 20%. When I am cooling this solution, we need to cool. When I am cooling this solution, I found that neither A nor B undergoes freezing at their corresponding freezing point. Again, when I am cooling this liquid phase, I found that neither A, that means component A, nor component B undergoes freezing upon their corresponding freezing point, since there is a presence of 20% of B. That means, consider we have already studied in colligative property that diffraction in freezing point directly proportional to molality, and it is directly proportional to n. More is the solute in the solution phase, there is a decrease in depression in freezing point. More is the solute in the solution, there is a net decrease in depression in freezing point. So since we are considering this A plus B liquid phase, that means 80 gram of A means 80%, it is our solvent. So A is our solvent and B is our solute. Since solute is 20% present, so we have found that when we are cooling the A plus B liquid, we found that neither A nor B solidifies, upon their corresponding freezing point. So here what happens here, found a point, this point consider point B. Point B represents freezing point of component where let 5 gram of A liquid is converted into solid. 5 gram of A liquid is converted into a solid means, since we have A plus B both are in liquid state, let us consider at point B some of the A liquid is converted into solid. So since 5 gram of A is converted into solid, then the solution have mass. Initially the solution of mass 100 gram, but since 5 gram of A is converted into solid, the solution of mass is equal to 95 gram. Then the solution composition changes. If the solution composition changes, then percentage of A, it will be equal to, initially 80 gram of A is present, 5 gram is converted into solid, so it have 75 divided by 95 into, and it will be equal to 78%. Percentage of B equal to 20, and it will be equal to 1. So again, at point B, some of the A liquid is converted into solid. Since at point B some of the A liquid is converted into solid, the composition of the liquid phases changes, in which the composition of B is increased. When the solution is 100 gram, then the composition of B is 20%. When the solution have mass 95 gram, then the composition is 21%. That means the composition also changes. So consider, here I am getting the composition, and this composition represents, this is 78% of A and 21% of B. 78% of A and 21% of B. Since the composition is changed, when I am again cooling this solution, since the solute percentage is increased, solute composition is increased, the freezing point also decreases. This is the point C, and this is the composition is 20, and this is the composition having 28. Consider at point C, let 5 gram of a liquid is converted into a solid. Since 5 gram of a liquid is converted to a solid, then solution phase have mass remaining 90 gram. Out of 90 gram, percentage of A will be 70 divided by 90 into 100, and the percentage of B will be 20 divided by 90, and it will be equal to 70 by 90 into 100, and it will be equal to 77.7% approximately. This is 2. Since at point C the composition again changes, why 5 gram of A is again converted into some of the solid, so A plus B liquid phase composition again changes. This is the new composition. Since in this composition the percentage of B is increased, solute is increased, so there is a net decrease in freezing point. So this is our point B, this is point C. Consider this is point. Let at point D not only A solidify but B also D, and this specific point D represents specific composition and specific temperature. This specific point D represents specific composition and specific temperature, that is, this is the composition and this is the temperature at which not only A solidifies but also B also solidifies. That means below this temperature we cannot separate A and B. Below this temperature we cannot separate, below this temperature we cannot separate A and B, and this specific point is called eutectic. This specific point is called eutectic point, and below this eutectic point we cannot separate solid A and solid B. And this whole is about what happens when if we have a two component system, that is A and B, and we have to separate A from B. So there is a point below which we cannot separate A and B, and this point is called eutectic point. So the graph will be like, if I am taking another system in which B is 80 gram, A is 20 gram, then the graph for B is like, and this is called our eutectic. At this point both A and B cannot be separated from each other, as both of them will be converted into solid.